Hey everyone. In this video, we are going to talk about eicosanoids. We'll talk about what eicosanoids are. We will talk about arachidonic acid, prostaglandins, leukotrienes, and by the end of the video, you should be able to describe the different types of eicosanoids. So what is an eicosanoid? Eicosanoids are similar to hormones, except they don't travel all the way throughout the body. They are synthesized and then they send a signal locally where they are created. So they're still a signaling molecule, but they don't travel through the bloodstream. So they are different from a hormone in that they are a localized signaling molecule. And they're all made from arachidonic acid, which looks like this. And so arachidonic acid is a 24 omega-6 fatty acid. It is one of those essential polyunsaturated fatty acids. So you have to get this in your diet. And I don't know if you ever heard of, omega-6s, but in the health industry, they're like, oh, get your omega-6 fatty acids, and they tell you to take like flaxseed oil and, things like that. They're good for you. You do need it. And the reason you need it is because your body uses it to make eicosanoids. There are two main types of eicosanoids that we'll talk about, the prostaglandins and the leukotrienes. So prostaglandins, uh, the name actually comes from prostate gland. Back in the archaic days of biochemistry, before chemists had a really good understanding of what was happening at the molecular level in the body, they were just collecting different body parts from butchers and they would grind them up and extract molecules and try and see like what molecules are in the body. They'd get like all the eyeballs from the butcher and grind them up and be like, oh, there's this weird molecule in eyes, and like, oh, there's this molecule in heart muscle. Oh, there's these molecules in the liver. Well, they ground up a bunch of prostate glands and they found a bunch of these molecules. So the name stuck, but ironically, they don't only exist in the prostate. That's just where they were discovered. These exist all throughout your body, but the name comes from prostate glands because that's where they were discovered. They are a carboxylic acid, which makes sense because they're made from arachidonic acid. And it's fused into a 5-membered ring. And it's got, two tails. The one tail has the carboxylic acid, the other one doesn't. And then they are oxidized at various points to have either alcohols or carbonyls sticking off of it. And there are like a dozen or more different prostaglandins. These are just two examples of some common ones. Their most common function is in inflammation response, but they also control like gastric secretions, blood platelet aggregation, uterine contractions, smooth muscle contractions, a whole host of physiological effects, but mostly they're associated with inflammation response. And so if we copy arachidonic acid here, you can kind of see how it's similar in structure. And if you let your mind wander, you can almost imagine how your body would turn this into these prostaglandins. It basically takes an enzyme and clamps down here and fuses a 5-membered ring. And then this is where you get the two tails from. And then it oxidizes different parts. So same starting material for all the different prostaglandins. And so when tissues get injured, they start converting arachidonic acid into prostaglandins, and then this triggers the inflammation response locally in that area. So like you hit your thumb with the hammer on accident, and your thumb's like, oh, we gotta, start the inflammation response. So it turns arachidonic acid into prostaglandins, which signal the inflammation response, the pain, the swelling. Non-steroidal anti-inflammatories like ibuprofen block the enzymes required to convert arachidonic acid into prostaglandins. And so that's how they work to stop inflammation, is they stop the conversion of arachidonic acid. The other type of eicosanoid are leukotrienes. These are also made from arachidonic acid, but they control different physiological responses. One of the main ones is the contraction of smooth muscles in your bronchioles in your lungs, and they are strongly associated with asthma response. So people with asthma have an overproduction of these leukotrienes. And you can once again see how, whoops, oh shoot, there. You can see how arachidonic acid is similar in structure, right? The 20 carbon chain here with the fatty acid, 20 carbon chain with the fatty acid. All your body does is oxidize it at different places and then maybe attach like some other molecules to it. But the core structure here in all of these comes from arachidonic acid once again. And so modern anti-asthma drugs function similar to NSAIDs by blocking the enzyme necessary to turn arachidonic acid into the leukotrienes. So if you stop the body from converting arachidonic acid into the eicosanoid, you stop the inflammation response and you stop the asthma symptoms. So traditional asthma treatments used to be like steroidal inhalers, which would lower the swelling, but they didn't stop the root of the issue. And so modern asthma medications actually block the enzyme that initiates the problem. So it stops it like right from the start. So you don't need to know about the drugs. That was just some interesting examples for you. What you do need to know are that eicosanoids are made from arachidonic acid, which is an essential amino acid. The two types are prostaglandins, which have this general structure, and the leukotrienes, which have these general structures. So that's it for this short video on eicosanoids. Thanks for watching. See you in the next one.